Before going into the lecture, kindly subscribe my channel. I am frequently updating my lectures, which are already uploaded in a very simple manner. So you can subscribe and you get my updated version of the video. Also share it and join my channel in order for the growth of my channel. Uh, Today, we are going to solve the example 2.2 of Griffith 4th edition Introduction to Electrodynamics. Example 2.2 is find the electric field a distance jet above the midpoint of a straight line segment of length 2L that carries uniform line charge lambda as shown in this figure. So this is the length L, and this is minus L here. So we have to find the electric field along the z direction. You know very well that electric field along the x direction will cancel because of the symmetry. So we can find the electric field along z direction. Let us say from the vector addition, that is, this is r, and this is x, and this is z. So this r vector, due to the vector addition, is equal to r cat. uh, R cat is the unit vector along the direction r, which is equal to z minus z cat, z cat minus x cat. That means r cat is equal to z cat minus x cat over r. So the small electric field due to the small charge q. Let us say we are taking a small length element in which the small charge is dq and the thickness is Tx. So the change in a small change in the electric field is k dq. Dq is the small charge under consideration over r squared r cat. Here we know very well that k is equal to 1 over 4 pi epsilon naught. 1 over 4 pi epsilon naught. So r cat we have found it here. So which is equal to z cat minus x cat over r. So this can be written as r squared into r. You will get r cube. So r cube z cat over r cube minus x cat r cube. The electric field along x direction cancels because of the symmetry. You have positive x direction and negative x direction, so this will become zero. Instead of carrying out integral finally saying zero, initially we will make it zero because of the symmetry. We are not just like that making it zero. Because of the symmetry, it will be zero. So we have only electric field along the z direction. So if you integrate this, you will get total electric field Ez, and k lambda. Here you have z. You can take z outside and integrate between minus L to plus L. Here you have Tx and R cube. We know from R is equal to Z squared plus X squared. Z squared plus X squared power 1 over 2. That is a square root of X squared plus Z squared. If you cube it, then this will become Z squared plus X squared power 3 by 2. Now we got this integral Ez is equal to k lambda z integral between minus L to plus L dx over z squared plus x squared power 3 by 2. So you can use the standard integral. Integral dx over a squared plus x squared whole power 3 by 2 is the value of this integral is x, that variable, that is we are differentiating with respect to x, so x over this constant. As far as this integration is concerned, we are integrating with respect to x. So a squared is a constant. So a squared square root of a squared plus x squared. This is the value of this integral. You apply here. If you apply here, you will get k lambda z. This integral, the value of this integral is equal to here x is the integral variable. So as far as this integral is concerned, z is a constant. So you can take you consider this as a. So 1 over z squared x over square root of z squared plus x squared. Of course, we have to apply the limit that is minus L. Lower limit is minus L, upper limit is plus L. So this will become here you can cancel this z and this z square. So this will become k lambda 1 over z, and if you apply upper limit, then this will become x is L over z square plus L square whole power half. And if you apply minus L, then minus of minus will become plus. Then this will be L over z squared plus L squared power 1 over 2, that is power half. So if you add this, the terms inside the bracket, you will get 2L. Uh, that is k lambda 1 over z 2L over z squared plus L squared power half. So here you can take 2L lambda. What is 2L is a total length, and if you multiply this by lambda, you will get naturally the total charge. So I have replaced this lambda and multiplied by 2L as Q. So this will become K 1 over Z multiplied by Q over Z squared plus L squared power half. This is the electric field along the Z direction. Now let us say test whether it is the valid solution or not. Let us take if k is very much greater than L. You can see here. You can ignore L squared here because L is very small comparing Z. So what is the value of Z squared power half? It is Z. Already there is one Z here. Then Ez will become K multiplied by Q, this Z into Z squared. So this is actually the electric field formula. Electric field is K Q over R square, where K is equal to, as I said already, 1 over 4 pi epsilon naught. Thank you very much for watching my video and supporting me continuously. Thank you very much.